So today we have an interesting system of equation. It says that if x plus y plus z is equals to 8 and square root of x square plus 1 plus square root of y square plus 4 plus square root of z square plus 9 is equals to 10, find the value of x, y, z. It's a very nice system of equation, and the cool part of this is that we are going to solve this with the help of geometrical method. As while solving the geometrical questions, we read some kind of algebraic equation, we solved, and we obtain the whatever is given, that's radius, area, or whatever we have assumed as the variable. Similarly, from that algebraic equation we can just create the geometrical diagram also. So we will use that only over here. So let us see that. So first one is very sweet and simple, x plus y plus z is equals to 8, and the second one is quite ridiculous, it's all of them squared and in radical. So no problem, let us see that. So first of all, as we are going to use the geometrical method, so we must have a thought this kind of geometrical diagram will give me this equation. So just concentrating on this second equation, look at it terms, it's x square y square plus 4 and z square plus 9, and one of them in under root. And these constants are also a perfect square, that are 1, 4 and 9. So it can be 1 square, 2 square, 3 square. So what this resembles is a right angle triangle. Yes, it resembles a right angle triangle for this first term. That's I am drawing in red. It is resembling a right angle triangle. Here's the 90 degree. Two of its side is x and 1. So because of the Pythagoras theorem, the hypotenuse becomes under root x square plus 1. Similarly, for second one, it's y square plus 4. So again draw a right angle triangle, and it's 90 degree over there. Its side would be y and 2, because 4 is a perfect square and it's of 2. So y and 2, so the hypotenuse becomes y square plus 4. And the third one, that's z square plus 9. So it, you can guess already, that's 2 of its side is going to be z and 3. So the hypotenuse becomes z square plus 9. So we have just figured out each of these terms, only the terms I am saying, not the whole equation we have figured out. Each of these terms we can figure out, means x square plus 1 is in a right angle triangle, y square plus 4 and z square plus 9. So all of them is in a right angle triangle. Now looking at this whole equation, all these three terms are added to get a perfect integer. So when here in this geometrical diagram, we can see now it's forming a line and its length is that particular terms. So if I have to add them, I have to just bring these three lines as a straight line. So when there's a straight line, we make points on it. So we can say distance of this plus distance of this plus this plus this is total length. So this happens when, means line segments join together to form a bigger line segment. So length of that all line segments added together gives the bigger one. So as we bring these terms as the line segment, now we will just arrange this right angle triangle in such a way that they can be added together. So I will just first draw it and then explain it. So here you can see already this three right angles triangle has been arranged like this way, and their hypotenuse, all of them has been added together. I am just naming over z, this 3, there is z, and this becomes z square plus 9. Similarly over here it's my y, here's the 90 degree, here's 2, so this much length from this point to this point becomes y square plus 9, not 9, it's y square plus 4, yes. And the last one from, means this length is x, this length is 1, and the hypotenuse becomes square root of x square plus 1. Now you can see this, all these three terms were first as the hypotenuse, now they have been in a straight line, so they can be all added together. So we can find the length of this total line, let us name that as AB, yes. So we can just find the length of this total AB. So it's already given that sum of this 3 is equals to 10. So we can say that AB from, that is from here to here, is equals to 10, yes. Now the second part to be observed, as this right angle triangle has been arranged, means inclined so perfectly, there's a special thing that this all three angles are going to be equal. Here it's alpha, so here it is also alpha, and here also it becomes alpha. These three angles are going to be equal because these two lines are parallel, you can see, because of the 90 degree. This and this line, let the color be changed so it will be visible. from here this lines are parallel, this and this. So according to the corresponding angle, this both angles got equal. It says that if two lines are parallel, here's the transversal, then this and this angles are equal. So similarly alpha and alpha got equal, and again this line is parallel, let it be color, yes, this line is parallel to this line, so again because of that property it becomes that alpha is equals to alpha, yes. So now the second thing, now what we are going to do is just extend this line perpendicularly from here, extend this from here, this both are perpendiculars, all of them are going to be a straight lines, yes. So now as this is equals to y, now all of them are perpendiculars from here to here, let that be marked quickly, yes, all of them are perpendiculars, so opposite sides are equal because it's definitely going to be a rectangle, yes. So if this side is y, so this becomes y, if this is 3 then this becomes 3, and in now this triangle, yes, rectangle we can say, that is 3, so this becomes 3, here it's x over there, so here it's become x, so here it becomes x, yes. Now look for the first data, that means the first equation, that x plus y plus z is equals to 8. So let this point over here be equals to c. So because of that we can observe over here the total length of AC, that's from here to here, is ultimately x plus y plus z, and that is going to be 8, yes, very nicely. And this length, that is BC, you can see, observe over here, it's 2 over here, so because of rectangle it becomes 2 over here, so 3 plus 2 plus 1, so its total length becomes 6, and here it's 10, and you can observe a 90-degree present over here also. Now again look in this biggest right angle triangle, it forms a perfect Pythagoras theorem, 8 square 64, 6 square 36, added together that's 100, and that's a perfect square of 10. So it's a right angle triangle, so everything has been fitted very nicely. Now let's solve for the value of x, y, z. That's very simple from now onwards, yes. So first of all, in this right angle triangle, this smaller one with the side x1 and the hypotenuse x square plus 1, the value of tan alpha, yes, the value of tan alpha is the perpendicular, that's x, and the base, that's equals to 1. And from that same angle, means this same alpha, now take the perspective of this biggest triangle, that's ABC. So because of that, the tan alpha now becomes the opposite, tan alpha now becomes the perpendicular, that's 8, and the base, that is 6. This is the perspective of the biggest right angle triangle, and this was with the x and 1, and it's 8 and 6. So now this LHS is equal to tan alpha, so their RHS can be compared, that is x is equals to 8 upon 6, that's 4 upon 3, and that is the value of x, very nicely, that x is equals to 4 upon 3. It has been solved very nicely. Now let us solve for the value of secondly, that's y. So again in this right angle triangle from here to here, you can observe again we have the same alpha, so again I can take the value of tan alpha. So tan alpha now becomes y upon 2 because of that triangle, the perspective of that triangle. So again comparing this and this, tan alpha is 8 by 6, tan alpha is y by 2, so ultimately y by 2 becomes 8 by 6, that is 4 by 3. So y is equals to 8 by 3, this shifted over there. So value of y is 8 by 3. And now for the final time we are going to see the tan alpha in this triangle, that is z3 and the hypotenuse. So in that triangle the value of tan alpha is z upon 3. So z upon 3, and already we have the value of tan alpha, that's 8 upon 6 and z upon 3. So they can be compared because the LHS is tan alpha. So 8 upon 6 is z upon 3. So 8 upon 3 is nothing but 4 upon 3. So 3 and 3 got cancelled out, so we obtained z is equals to 4. And that's the final set of solution, that x comma y comma z is equals to 4 upon 3 comma 8 upon 3 comma 8. It's the solution to this question. You can see it's very nicely solved. All you need to do is just arrange them in a geometrical diagram, and then a little bit of very normal trigonometry. You can use anything, it can be solved. After this diagram you can use the basic proportionality theorem also, but it was solved using the tan instead trigonometry, so I make you use that only. So x, y, z has been found very nicely, that's 4 by 3, 8 by 3 and 4. Here it's not 8 in the final solution, here it's 4. So you can observe in this that this algebraic equation was solved very nicely using the geometrical method, and at last when 8, 6 and 10 got fitted correctly, this geometrical diagram was absolutely correct. So means whatever you make, there must be no kind of contradiction then, and then only it's correct. So this geometrical diagram was correct, so this solution came out very correctly. That's 4 by 3, 8 by 3 and 4. So if you have any other method to solve this system of equation, whether it's algebraically or else geometrically, I would prefer if you have geometrical method. So if you have any other method other than this, you can do comment below, or else you can DM me on my Instagram, link is in the description. Also, you can just suggest me more cool problems, not only the solutions. So when we give our viewers more and more questions and solution, it spreads the knowledge.